In order to find this product, I have set up a 2 by 2 box, so we just need to find the products in each square and then combine like terms. Top left we'd have 5x squared, we'd have a negative x here, 60x, and then minus 12. These two are like terms, so we get 5x squared plus 59x minus 12 for our answer there. For number 2, I set up a 2 by 3 box, or sorry, not a 2 by 3, a 2 by 4, being that it's binomial times a polynomial with 4 terms. We still just find our different products. Again, being very careful that we find those products correctly. And then we go to the bottom, so we get 12m cubed. Now we are going to have several pairs of like terms here, the m cubes, the m squareds, and the m's. Starting with our highest degree though, we have 16m to the 4th minus 8m cubed minus 23m squared minus 14m minus 6 is what we're looking at. For number 3, I did not set up a box because this is our sum and difference pattern. You can see the pattern there, a minus b times a plus b is a squared minus b squared. So all I would look at doing there would be squaring the 9r's, so that's 81r squared, and then minus 7 squared, so 49. Again, if you wanted to box or FOIL that out, you could, but the pattern is a very quick way to figure that out. For number 4, same sort of deal. This is the square of a binomial pattern, specifically the square of a sum of terms. And we can see the pattern there, so all I need to do on this is square the 5m, so I get 25m squared. And then it's the product of the two terms doubled, so product of 5m and 9 is 45m, double that, we get 90m. And then squaring the 9, I get 81, so that's what we're looking at there. Here we're just dividing the trinomial by a monomial, so we divide each term by the monomial. So we get 7x to the second minus 4 plus 2 over x squared. This first division here is fairly straightforward, just a trinomial by a binomial. Starting off with that x squared divided by x, which gives me x. My product, x times x plus 7, gives me an x squared plus 7x. Notice the signs are the same on my divisor, so I'm going to be subtracting both. So subtracting the x squared and the 7x gives me 5x plus the 33. Now my degrees are the same, so this will be my last time through my process. I get 5x divided by x, which is 5, so that's the last part of my quotient. Then I need to find the product of 5x plus 30, or 5x plus 5 times the x plus 7, which is 5x plus 35. Again, my signs are the same, so I'm really subtracting both of those. So we just get a remainder of negative 2, so the actual answer would be that x plus 5 plus the remainder of negative 2 over the divisor x plus 7. So that's what that would look like. For number 7, one thing I did do was to switch the signs on the numerator and denominator. Notice how the denominator is negative 2x minus 1, so rather than dealing with that the whole time, I just decided to take the negative out of the numerator and denominator. So notice how it's a 4x cubed minus 4x squared and minus 9x minus 3. So you wouldn't necessarily have to do that, but that's one way we can get rid of that negative. So for my process here, we begin by dividing the 4x cubed by the 2x, so that gives me 2x squared. So I need to find that product between the 2x squared and the 2x plus 1. And so I get a 4x cubed plus 2x squared. Again, notice the signs are the same, so I'll be subtracting both of those. So subtracting the 4x cubed, subtracting the 2x squared. So it gives me a negative 6x squared, and the minus 9x and minus 3 just come down. So I continue my process, divide the negative 6x squared by 2x, I get negative 3x. I need to find that product, negative 3x times the 2x plus 1. So I get a negative 6x squared minus 3x. Again, same sign, so I'll be adding both of those, adding 6x squared, adding 3x. So I get a negative 6x minus 3. So one last time through my process, negative 6x divided by 2x is negative 3. Find the product of negative 3 and 2x plus 1. So I get negative 6x minus 3, so adding both of those, adding 6x, adding 3, so we get a 0 for the remainder. So really the answer, just being that quotient on top, 2x squared minus 3x minus 3, is all we have there. Then for our final problem, we have a polynomial divided by a trinomial. Again, doesn't change our process. We still go through all the same steps. But we begin by dividing the 8z to the 4th by the z squared. So that gives me 8z squared. So I go up here. I need to find the product of the 8z squared and the z squared minus z plus 2. So if I come over here, 8z squared, z squared minus z plus 2, and so I get 8z to the 4th minus 8z cubed plus 16z squared, like that. So I'm subtracting that, so I switch all those signs. So subtracting the 8z to the 4th, adding the 8z cubed, and subtracting the 16z squared. And let's see, so we get a 2z cubed, and we get a negative 3z squared plus 4z plus 2 just comes down. So then I start my process over again by dividing the 2z cubed by z squared. Of course, that gives me 2z. So that's the next part of our quotient. And I need to find the product of the 2z and the z squared minus z plus 2. Lots of z's and 2's in here. 2z cubed minus 2z squared plus 4z. So again, we're subtracting that, so we'll switch the signs. So we'll go minus 2z cubed plus 2z squared minus 4z. So interesting situation here where the z cubes cancel out, the z squareds do not. We still have a negative z squared, but the z's cancel out, and so I just have that plus 2. So I start my process again by dividing the negative z squared by z squared, which I get negative 1. So that's the last part of my quotient. So I need to multiply the negative 1 by z squared minus z plus 2. So I have a negative z squared plus z minus 2. So again, I'm adding the z squared, subtracting the z, and adding the 2. So the remainder ends up being a negative z plus 4. So the actual answer would be the 8z squared plus 2z minus 1. Plus the remainder of negative z plus 4 over the divisor, which was our z squared minus z plus 2. that is it for our final problem. Hopefully this helped.